The third design is two groups, randomized, pre-test, post-test design. So now they are randomized. Before randomization, you can do the pre-testing. Suppose you have selected a school by sampling technique. One school you have selected. Now in that school you have also selected a class. And now you want to have two groups in that class. You can give them a test on mathematics, and on the basis of their achievement in that test, you can randomly match them and also randomly put them into groups. But you have given them a pre-test on that particular subject. Film appreciation. Let us take that same example. When you see a film, how do you appreciate that film? Do you really see where the director is seen? What are the symbols? What are the processes? What are the scenes which tell you here is the director? We don't know. We generally see that, and when we see the scenery, so nice. That's not the way we should appreciate a film. So first I can give you a test how you appreciate a film. I will show you a film and will give you a test. And I will know that this is how you appreciate a film. Then I will give you an appreciation course. How a film should be appreciated. Then I will again show you another film and give you the test. So then I will know whether your appreciation skills, attitude towards film has changed or not. Because of my attitude. That was, I had designed a course, say of 3 days. Whether that really changes the way people appreciate the film. So I can do this for two groups. One group I don't give them appreciation course. I give appreciation course only to my experimental group. But before that I am testing both the groups on their way they are appreciating a film. Now you have two choices. One is on the basis of pre-test, you match them and group them. But suppose it is not possible. One group is at Borivali and other group is at. These are the two groups which were ready to be. So can you group them like that and tell Bhandu people you come here when I am conducting an appreciation? It's not possible. It is possible but it's difficult. So what we can do? We give them the pre-test and then we use statistically, we randomize them and show that because they were selected randomly, they are equal. And then we will see that how analysis of covariance is used. And then we will say that whether the course appreciation course has increased the way you appreciate it. So here what we are doing, we are giving pre-test to both, post-test to both, but we are not, see, if you equate them, then you are not taking those scores for gain. Otherwise what you can do, gain for the experimental group. The experimental group average was 10 and after the course it was 40. Control group's average was say 12 and they did have a course. After 3 days again you give them another film for appreciation. Their score was 16. So because of the passage of time they got 4 scores more. But here 10 to 40, that means 30 scores are increased. So you can do analysis of gain in the score. Once you match them, then there is no need for taking that gain also. I will just show you this. If these are same, average, we are talking about average. This is experimental group and this is also average. This is control group. If they are same, then we will take care only about their post-test. Now suppose this is post-test. Then we will only see the difference in T3 and T4. We said this was 10 and this was 12. This became 40 and this became 60. So So now these are more or less equated. We don't have to take this for analysis, this is only for analysis. But suppose originally they do not match, you are randomly put them, because one group randomly you said this is going to be experimental, another randomly you said this is going to be controlled. And if you test their pretest is given and there is a difference, then what you can do, you take a difference in this and difference. This difference is 10 and this difference is 4. Then statistically you find out whether this difference, this is called gain, G-A-I-N, gain. Gain after the experiment and gain after some days of whatever for control group. Because control group we have not given any treatment. So both ways analysis can be done. Analysis of variance and covariance if you do, it will take care of all four. You don't have to do anything because that itself will take all the scores, pretests and post. You will see how it is to be done when we go for statistics. The fourth design is randomized Solomon three group design. What is it? There is one experimental group and there are two control. Why two control groups? Please study that. Please remember those threats to internal validity. We said if you give the pretest, it may affect your treatment. So, we are comparing two groups with pretest and one group with only post-test. So, you will also know whether pretest is really affecting. Because the third one is only post-test. There is no pretest. But why it is called control group when we are giving treatment? Generally, we don't call it control group. Control group does not have treatment. But here we want to study the effect of pretest. So, for the first one, pretest is given and second one, pretest but no treatment. And the third one is no pretest but treatment is there. So, how you will take first and second will tell you a difference in the treatment. And the first and third will tell you the difference in treatment. Right? First and second means experimental group and control group 1. Now forget about control group 2. How you will compare them? Both are given pretest. So you have both the marks. Either you must have matched them or you can do it statistically. But what you are interested in? Post-test. Now the difference in post-test will be because of treatment. Correct? Because one group has got treatment, other group has no treatment. So that is the only variable which is affecting. So if there is a change, it is because of your independent variable. Now someone will say, your pretest was given, so that is affecting. So we want to see now experimental group and control group 2. Now forget the middle one. Both have post-test, both have the same treatment. But one has a pretest and other does not have a pretest. So now you will see if there is a difference, there is a treatment and there is a post-test. So if they should be equated, post-test there should not be any difference, isn't it? Theoretically, same treatment is given, so post-test also should be same. So what you can see, say that treatment is effective. But suppose they are not same, then why that there is a difference? It is because of the pretest. See, as an experimenter, you always have to see, is something else affecting my variable? Because we are solely interested in dependent variable, correct? But dependent variable should be affected only because of independent variable and nothing else. That is a causal effect, cause and effect relationship which we are trying to establish. There should not be 3-4 causes. There can be, but right now we are saying there is one cause and whether that is a cause for effect, that is what we want to establish. you might say this is not a cause. How did they find that the fever which you get, it is because of the bacteria which have gone into your stomach when you ate something? You have not seen them going inside, right? How does that scientist know? He or she must have conducted several experiments. Is it because of this? No. Is it because of this? Then they eliminated several possibilities and then they said yes, it is because of this. So you also might have, before coming to a conclusion, that this is the cause of this. That is why we are conducting the experiment. We are not showing there is a relationship. We are saying that relationship is causal relationship. There are two variables. One is independent variable and other is dependent variable. Which is the cause? Correct. Independent variable is the cause. And it is causing change in the dependent variable. Oh, I like that. So, independent variable, your treatment is the cause, and if it changes your dependent variable, that is causing the change. That is what we want to establish. That's why we are conducting the experiment. Please understand. So, if you don't see any difference, then what you can say? This is presumably, now what I see, this is not the cause, because both the groups have the same result. It may not be a cause. So, it has to be further explored. We right now, even outside we don't say this is not a cause. We say that anything might have gone wrong. We do not know. We have seen 8 different traits. Even without our knowing, suppose out of 20 students, 10 had some bad experience at home with their parents. You don't know. You don't have any control. You are only seeing them in the class. So, we are not outright saying scientists deal with chemicals. So, they are predictive. And we work with human beings who are not so predictable. There are many variables which affect them other than what we do. The last one is randomized 4-group design. There are 4 groups: experimental group and 3 control groups. 2 groups have pre-test, 2 groups do not have pre-test. 2 groups have treatment, 2 groups do not have treatment. And all 4 groups have post-test. Now you study this and tell me what is the difference in the 3rd group and 4th group. This was 3rd group. Experimental group has all 3: pre-test, treatment, post-test. The first control group naturally does not have treatment, but pre-test is there, film appreciation. Test is given and no course is given, and directly post-test. Correct? You know this. So, if you see a difference between these first 2, you are going to say it is because of the course. Now, let us go to control group 2. It is like the column 3 groups. There is no pre-test. So, it will tell you that whether pre-test is affecting. Please remember, the statistics used for this is very complex. I am not teaching you statistics right now. We are only to understand the logic, why we are doing this. You would say, if 2 groups are enough, why do we want to go for 4 groups? Why do we want to do with 3 groups? Because additional cost is there. Not only money, but your time, expertise, so many variables. Then why do we do that? So we are interested in many other things. That's why we are doing column 3 or column 4 group. The 3rd is control group 2. There is no pre-test. So like column 3 group, it will give you the impact of pre-test. But there is a treatment and there is a post-test. What happens in control group 3? Only post-test. There is no pre-test, so it doesn't have pre-test effect and there is no treatment, so you can say that no treatment is given. So you can give them only course. Different statistics we use for 4 groups, and then we come out with a finding saying that whether the treatment was effective, whether the pretest affected any of your dependent variables, and whether they had interaction effect. We have said, no, so interaction effect is also there. So interaction effect means there are 2 variables interacting. See, generally what happens if you take socioeconomic status, that is economic status, and education of parents. They can be rich, and parents can be Anguta Chap, that is possible. And parents can be rich, and they can be PhDs and professionals. So both these affect their scholastic achievement or their attitude or various variables. It's not independent which we are interested in. So sometimes we are interested in interaction effect, and that's why there are statistics, F ratios and many other statistical tools are available which would tell you, isolate what your treatment really says. Because we are only interested in treatment. We want to take out all other things, and this is how we take those things out. And you will come out only with the effect of treatment on the dependent variable. Okay. These were true experimental designs. Why did we call them true experimental design? What was the common thing? Single group, all are 2 groups, 3 groups, 4 groups, more than 2. But why are they called true groups? True experimental design. Correct. Every time the subjects are selected using randomized thing. Please understand that. And random does not mean isko pakad ke lao idhar rakho. No, not like that. We are doing it randomly means statistically random business. Please understand that. So somebody asks you what is random? Not anyone. It has a specific definition. The experiment differentiates from pre-experimental design to true experimental design only because of randomization. Because the experimenter has full control over the experiment. So which one you should opt? True experiment, right? Now let's see 2 more.